So we're talking about the intermolecular forces today. So intermolecular forces are the forces between the molecules. We've studied bonding completely and we know how atoms and molecules bond together. Now they exert certain forces between those molecules as well. For example, let's say if we have a Cl2. Cl2 is a compound that has two chlorine atoms, okay? And these two chlorine atoms are bonded by sharing of electrons because it is a covalent bond. Now, what happens is that uh, for example, there's another chlorine. These two chlorine compounds will attract each other, and that force between the two compounds is known as the intermolecular force. So force between two molecules or more than two molecules, multiple molecules is known as the intermolecular forces. We study three types of intermolecular forces in the AS syllabus. Number one is the um, van der Waals. Number two is the hydrogen bonds. And the third one is the permanent dipoles interaction. So let's start off with van der Waals first of all. Van der Waals is the weakest intermolecular force that is present, and it's also known as induced dipole forces. This is another name, and London dispersion forces is another name for van der Waals. So van der Waals exists for non-polar molecules. We've studied the polar and non-polar molecules in previous lecture. You already know the difference between the two types of molecules. A polar molecule is the one that has dipoles on it, and a non-polar molecule is the one that doesn't have any dipoles on it, which means that there's no difference in the electronegativity values of the two atoms joining in a non-polar compound. Okay, so it must be non-polar. The two compounds must be non-polar over here to have van der Waals. And what happens is the van der Waals are basically created by the collision of the two atoms and movement of electrons as a result of those collisions. Okay, so I'll draw these diagrams here for you, just for your understanding. So first of all, just write that it is the weakest intermolecular force. Um, Electron charge clouds are there on non-polar molecules, and those charge clouds are constantly moving. So you can write that electron charge clouds on non-polar molecules are constantly moving. So what happens is that the electrons, when the molecules collide, the electrons move to a side on temporary basis. So for example, could you name a non-polar molecule for me? Well,
Sorry, can you repeat?
yeah, I'm saying, can you name a non-polar molecule?
Non-polar. Um. Non-polar. Cl. No.
Yeah, Cl2.
Cl2.
Any diatomic substance is non-polar, yeah, because both of the atoms in a diatomic substance are exactly the same. They're in the same place of the periodic table, and they have no difference in the values of their electronegativities. Okay, so let's take Cl2 as an example. So if you have a Cl and a Cl and then another Cl, because intermolecular forces are there between the two Cl2s, okay? So there will be, these Cl2s will be moving. So this one is going to collide with the other one and the second one is going to collide with the first one. So after the collision, what happens is that, let's say the electrons over the Cl2s all moved onto the first chlorine, and there was no electron in the second chlorine. So as a result, the resulting structure would look something like this. There will be a partial dipole, a negative one on this side, a positive on this side. Why? Because the electrons are now on the left hand side. So most of the so this left hand side will have a temporary negative dipole. All right.
But
Whereas
don't like ऐसे नहीं होता कि दोनों क्लोरीन तो सेम है तो दोनों का चार्ज सेम नहीं होगा?
नहीं, सेम नहीं होगा, क्योंकि दो डिफरेंट एटम्स हैं. चार्जेस एटम्स पे आते हैं, पूरे कंपाउंड पे नहीं आते. ठीक है.
लेकिन दोनों में टू टू ही है.
दोनों में क्या इलेक्ट्रॉन्स शूट हुए हैं?
नहीं मतलब लाइक टू क्लोरीन्स हैं लाइक
हाँ,
इस
यहाँ
वाले में भी. तो ये
इस वाले
कैसे
में
हो
भी.
गया कि सेपरेट है?
आई एम स्टिल नॉट
लाइक
गेटिंग योर क्वेश्चन.
लेफ्ट साइड का ज्यादा है चार्ज और राइट साइड का कम है, ऐसे क्यों है?
एक ही क्लोरीन के अंदर क्यों ऐसा हो रहा है? एक ही Cl2 स्ट्रक्चर के अंदर.
हम्म.
ये इलेक्ट्रॉन की देखो, इलेक्ट्रॉन क्लाउड्स मोबाइल होते हैं, दे कैन मूव एट एवरी इंस्टेंट. क्लोरीन खुद से कोलाइड करेगा, किसी और स्ट्रक्चर के साथ कोलाइड करेगा, ये इलेक्ट्रॉन क्लाउड्स मूव करते रहेंगे. ठीक है. तो अब हुआ ये कि कोलिजन की वजह से, लेट्स से कोलिजन इस तरह हेड ऑन हुई है, तो इलेक्ट्रॉन सारे राइट लेफ्ट पे चले गए हैं. अब जब इलेक्ट्रॉन्स लेफ्ट पे आएंगे तो वो साइड ऑब्वियसली ज्यादा डोमिनेट करेगी नेगेटिव चार्ज में, बिकॉज देयर आर मोर इलेक्ट्रॉन्स, एंड व्हेन देयर आर मोर इलेक्ट्रॉन्स तो डेफिनेटली नेगेटिव चार्ज ज्यादा है वहां पर. इसलिए हम कह रहे हैं कि वहां पे नेगेटिव चार्ज डोमिनेट करेगा. अच्छा, अगर यहाँ पे नेगेटिव चार्ज डोमिनेट करेगा तो ऑपोजिट साइड का मतलब क्या है? उसमें ऑब्वियसली पॉजिटिव चार्ज डोमिनेट कर रहा होगा, राइट? तो इसलिए ये टेम्पररी डायपोल सेटअप हुए, ये परमानेंट डायपोल्स नहीं है. इसलिए हम कहते हैं कि दिस इज ए नॉन पोलर स्ट्रक्चर, इट कैन नॉट हैव परमानेंट डायपोल्स. ये टेम्पररी डायपोल्स हैं जो भी खत्म हो जाएंगे. सिर्फ ये इसलिए आ रहे हैं ताकि ये वैन डर वाल्स क्रिएट कर सके. होगा ये कि then both of these Cl2s will collide with the Cl2. Now, because the right side of the chlorine has a positive dipole, a temporary positive dipole, the left side of the other structure will have a temporary negative. Again, electrostatic attraction, positive, negative. Or if this right will have a negative, तो इसका जो sorry, if this left is gonna have a negative, तो इसका जो right है उसका positive आ जाएगा for the electrostatic attraction. अब ये पॉजिटिव इस नेगेटिव को अट्रैक्ट करेगा, और यहां पे जो फोर्स सेटअप होगी वो हम कहेंगे वैन डर वाल्स है. इसीलिए आप इसको कहते हो इंड्यूस्ड डायपोल्स. आपने फिजिक्स में इंडक्शन पढ़ा होगा. इंडक्शन क्या होता है? मैग्नेटिक इंडक्शन. डिड यू स्टडी इंडक्शन इन फिजिक्स?
अभी नहीं, आई थिंक वो सिलेबस से निकल गई थी.
अच्छा, तो इंडक्शन बेसिकली होता यह है कि व्हेन डायपोल्स or any poles in terms of electrostatic forces are set up on compounds, on structures, on objects without the physical interaction of those objects. आपने, if you must have experimented this, बचपन में आपको एक कराते होंगे कि एक पेपर पीसेस आप रखो नीचे, आप हेयर ब्रश करो और फिर उनको अट्रैक्ट करो, सारे पेपर पीसेस उस हेयर ब्रश पे अट्रैक्ट हो जाते हैं. Have you experienced have you done that?
यस.
और अगर आप हेयर ब्रश को कांटेक्ट में नहीं भी लाओ पेपर के साथ, फिर भी वो पेपर पीसेस अट्रैक्ट हो जाएंगे आपके हेयर ब्रश के साथ. Why? Because there is this process of induction taking place. Induction is when you bring opposite charges close enough without having a physical interaction, those objects attract. All right? आपने ये देखा होगा, आप बलून को रब करो बहुत देर से किसी वॉल के साथ, आप उसको वॉल के करीब लाओगे, वो स्टिक कर जाएगा, वो फाइनली एक फिजिकल इंटरैक्शन डेवलप कर लेगा. लेकिन बिफोर दैट फिजिकल इंटरैक्शन you'll experience an attractive force between the balloon and the wall. Yeah, that is the induction process. तो एग्जैक्टली वही कॉन्सेप्ट यहां भी हो रहा है. क्लोरीन के ऊपर एक डायपोल पॉजिटिव इंड्यूस हो रहा है, उसके वो अब इसके करीब भी आएगा ना दूसरे क्लोरीन के साथ, तो उसके दूसरे क्लोरीन के ऊपर एक नेगेटिव डायपोल इंड्यूस हो जाएगा, और उसका नेगेटिव डायपोल फिर उसके साथ वाले के ऊपर पॉजिटिव कर देगा. फिर एक और क्लोरीन होगा यहाँ पे जिसका नेगेटिव और जिसका पॉजिटिव अट्रैक्ट करेगा, इसके पॉजिटिव के साथ एक और क्लोरीन नेगेटिव और उसके साथ एक और क्लोरीन पॉजिटिव. या सो दिस इज हाउ द चेन कंटिन्यूज. आई होप दिस इज क्लियर नाउ.
यस.
Okay. Now we are moving on to hydrogen bonds. Hydrogen bonds are basically the strongest type of intermolecular force, and it exerts under certain conditions. So there are two conditions that you need to fulfill in order to have hydrogen bonds. Number one, you must have either oxygen, nitrogen, or fluorine covalently bonded to hydrogen. So whenever you'll have oxygen, nitrogen, or fluorine bonded to hydrogen, only then there will be a chance of hydrogen bonds being formed. And the second condition is that there must be lone pairs on oxygen, nitrogen, fluorine. So let's take an example, HF, hydrogen fluoride. Now, if you focus, HF, hydrogen fluoride um, is a hydrogen halide where fluorine is bonded to hydrogen. Your first condition is done, yeah? So you can have hydrogen bonds because fluorine is bonded to hydrogen in this case. Now, if you focus on the structures, if you draw these covalent dot and cross diagrams, you'll notice that there will be a sharing pair between H and F, and then there will be lone pairs on fluorine as well. 3 lone pairs on each fluorine. So these lone pairs, if there are lone pairs present, you're satisfying the second condition as well. So you can say, yes, okay, now you can have the hydrogen bonds because both of the conditions have been satisfied. O, N, or F, in this case, fluorine is bonded to hydrogen, and fluorine also has lone pairs. So now what happens is that the force between these two HFs, the intermolecular force, is known as the hydrogen bonds. A property of hydrogen bonds is that this bond is very highly polarized because the dipole is very, very strong on hydrogen bonds as compared to a normal dipole. So you can say, you see HF is a polar molecule because fluorine and hydrogen have different values of electronegativities. They will have dipoles. Fluorine will have a partial negative dipole and hydrogen will have a partial positive dipole. So their dipoles are generally very, very strong. Stronger dipoles than normal dipoles. So this is a characteristic that the dipoles of hydrogen bonds, molecules forming hydrogen bonds, will be stronger than any other molecule. And because there are lone pairs available on either fluorine, oxygen, nitrogen, the negative charge density will be a lot higher on them. Negative charge density is the per unit electrons on a substance. जितने ज़्यादा electrons होंगे उतनी charge density ज़्यादा हो जाएगी. So this is another characteristic that negative charge density is higher on O, N, or F, right? We're going to look at water as an example. H2O is also a compound having hydrogen bonds, a very common compound जो हमें पता है. Water का structure किस तरह होता है? H, O, and H. Hydrogen bonded to oxygen. Oxygen has 2 lone pairs. Then with these 2 lone pairs, more hydrogens are bonded. And with those hydrogens, you see there are more oxygens. Those oxygens also have lone pairs. फिर उनकी आपस में bonding हुई हुई होती है. तो ये this is how this is how a structure of water looks like. ये यहाँ पे फिर O, फिर H. See, this is how the structure continues. So the lines that I've represented, ये वाली जो lines हैं, these are basically hydrogen bonds from one molecule to the other molecule, one molecule to another. So these are the hydrogen bonds over here. I hope this is clear.
Yes, लेकिन हाइड्रोजन बॉन्ड लाइक सिर्फ ऑक्सीजन, नाइट्रोजन और फ्लोरीन के साथ ही हो सकता है.
बिल्कुल, हाइड्रोजन का इन
और
तीन
कोई
में
नहीं
से
है.
किसी एक के साथ होना जरूरी है, अदरवाइज नहीं होगा.
Okay.
इसकी let's look at the effects of hydrogen bonding. If a compound has hydrogen bondings, उसके उस compound पे क्या effects होंगे? Number one, because it's the strongest type of intermolecular force. तो जितनी force strong होगी, आपको पता है कि it will be difficult for you to remove this force, yeah? जितना stronger होगी. एग्जाम्पल, कोई भी चीज जितना ज्यादा टाइड अप होती है, कोई अगर बहुत टाइटली टाइड अप होती है, उसको ओपन करना उतना ही मुश्किल होता है, उतना ही ज्यादा फोर्स चाहिए होती है. तो हाइड्रोजन बॉन्ड इज, think of it as an interaction between the two compounds, the stronger the force is, it gets difficult for you to remove that force or to somehow break the molecules. All right. So, and how do you remove these forces? In chemistry, you either melt a substance or you either boil a substance. Yeah. If an ice, let's say, is tightly packed, ice is a solid structure, you melt the ice to convert it into water, and that is how you break the strong bonds of ice. And then once you boil that water, you convert it into gas. That is how you break the bonds in the liquid as well. So in chemistry, you either melt or boil to break these bonds. So if hydrogen bonds will be there, the melting and boiling points will be very high as compared to normal molecules. So the first effect of hydrogen bond is higher melting and boiling points. An example of this could be a graph having all the hydrogen highlights, for example, HF, HCl. So see, we're adding all the halogens of group 7 with these hydrogens, HBr, HI. And on the y-axis, let's say you're given with boiling points. So if you compare the boiling points, सबसे पहले तो HF will have the highest boiling point. Why? Because it is hydrogen bonded. The intermolecular force is the hydrogen bonds in HF. Then the boiling point of HCl will be the lowest. Why will it be the lowest? Because if you focus, HCl has it has permanent dipoles. All right. There's no hydrogen bonds here, and then generally the boiling points continue to increase because of the structure of these compounds. All right. So only high HF had the highest boiling point because it had the hydrogen bonds. This is how hydrogen bonds affect the boiling points. And the regular structures they follow the normal trends. So now another point here is that ice is less dense than water. If you weigh ice and water, you'll see that the density of ice will be lesser as compared to the density of water. Why is that so? You need to write these reasons as well, because you see we've just drawn the structure of water here. The same structure will be of the ice as well. If you focus, this is a tetrahedron. It's a tetrahedral structure. What happens is when ice is in when water is in liquid state, it can constantly move. As soon as it freezes, the oxygens are surrounded by a tetrahedron of hydrogens. You see, every oxygen has hydrogens around it. And this tetrahedron of hydrogens basically creates gaps. And those gaps allow air pockets. And because of those air pockets, the density is further reduced. Is this clear?
Yes.
So molecules in liquid state are moving. They freeze. Once they freeze, what happens is that oxygens get surrounded by tetrahedron of hydrogens. Then, because of that tetrahedron structure, gaps are created. And those gaps reduce the density. Reduced density, finally. This is why ice has lesser density than water. Now, moving on to the permanent dipoles, the last intermolecular force. Permanent dipoles are the strongest dipoles. By the name, you can see that this type of interaction is only true for a polar molecule. Number one, the molecule has to be polar. Why? Because dipoles होंगे तो permanent dipoles होंगे ना. So remember we studied how dipoles are considered to be strong and weak. You remember? Can you tell me how do you differentiate between strong and weak dipoles?
By their charges.
Charges?
I mean, by the I'm confused.
HF और HI या HCl और HI, चलो चार्जेस तो सेम है, पॉजिटिव नेगेटिव पॉजिटिव नेगेटिव। अब हमें कैसे पता लगेगा HCl ज्यादा स्ट्रांग है या HI के डाइपोल ज्यादा स्ट्रांग है? नहीं, नो आइडिया। अच्छा, so let me tell you. You look at their positions in the periodic table. HCl और या HI में से हाइड्रोजन से लेके क्लोरीन या आयोडीन जाने में किसमें आपको ज्यादा टाइम लगेगा? Iodine is further apart from hydrogen, right? Hydrogen is on the same place. Chlorine तक जाने के लिए go on to group 7 and one step down you'll get to chlorine. लेकिन you need to go further a step down to get to iodine. Iodine is further apart. You see, iodine is further apart from hydrogen. So the distance, as the distance increases between the two atoms in the periodic table, their electronegativity values increase. And when the electronegativities increase, the dipoles become stronger. Okay, so HI has stronger dipoles. And whenever the dipoles are stronger, you call them permanent dipoles. Strong होंगे तो आप कहोगे कि permanent dipoles. वो आप समझ आई?
Yes.
तो जब भी permanent dipoles होंगे, अब अगर HI का एक मॉलिक्यूल एक और HI को अट्रैक्ट करेगा, तो इसके दरमियान की जो फोर्स होगी वो होगी permanent dipoles interaction. ठीक है, लेकिन the first step over here is to figure out whether your compound has permanent dipoles or not. All right, and that is and you figure that out by looking at the difference in the values of the electronegativities. All right, ठीक है। अच्छा, एक छोटा सा concept regarding van der Waals before we end the topic, that is कि van der Waals की दो properties होती हैं. As the molecule size increases, size of the molecule and surface area of molecule, जितना ज्यादा size होगा, जितना ज्यादा surface area of molecule होगा, उतनी ज्यादा van der Waals होंगी. So if the size of molecule will increase, the van der Waals will also increase. If the surface area of the molecule will increase, the van der Waals will also increase. इसकी example क्या है कि आपके सामने मैं दो structures draw कर रहा हूँ. C2H6, this is an ethane structure, and the second one is C4H10, a butane structure. So if you notice, can you tell me which one of these two structures is bigger in size and bigger in surface area?
C4H.
C4H10, because it has more carbons, and the first one has 2 carbons and 6 hydrogens, the second one has 4 carbons and 10 hydrogens. So this one is bigger in size, it has greater surface area. तो इसका मतलब ये है कि this will obviously have more van der Waals. More van der Waals का मतलब क्या है कि इसकी intermolecular force strong है. It is more strongly bonded. You will need a more amount of energy to break these hydrogens and carbons, right? So you can expect इस तरह के questions in your MCQs, where you will be given with different compounds and you'll be asked to distinguish between which of the compounds have greater melting points, lesser melting points. ठीक है, किसमें van der Waals ज्यादा हैं, किसमें कौन सी फोर्स ज्यादा है, तो ये चीजें आप एक्सपेक्ट कर सकते हो. Is the topic clear now?
Yes.
Have you also written down the notes?
I did. Can I look at the polar molecule ones again?
Yes. This one. Do you want me to zoom onto it?
Yes.
Okay. अच्छा, with that I will be assigning you an assignment, क्योंकि हमने we were done with the first 3 topics, moles, atomic structure, bonding. ठीक है, so you're already given with a bonding test as well, which I'm expecting that you'll be submitting it to me by today. Secondly, we need to do a few assignments as well, क्योंकि आप अपनी तरफ से जो टॉपिकल्स कर रहे हो वो तो ठीक है, that's for your own practice, but I want you to just let me just turn off the